Okay, everyone, we are moving on to lesson 5.5. The topic is solving polynomial equations. Now, this is going to be split into two parts, part one today, of course, because to solve the equations, we need to focus on factoring. And before break, we did review a bit of factoring that's highlighted here, or contained here, common factoring, trinomial factoring, difference of squares. But there are other types of factoring we need to learn called grouping, quadratic form, sum of cubes, difference of cubes. And so what I'm going to do is I'm going to highlight and focus on the factoring part today, and then in the next lesson we will get into the actual solving part of the equations. If I try to do it all in one day, it would just be an hour-long video and you would probably be pretty miserable. So, as I go through this, I'm going to assume you know the common factoring, trinomial factoring, and difference of squares because that has been covered. But I will be, so when it comes up, when those things come up in this lesson, I'm just going to go through it like you already know it. But for these other things, I will teach them as brand new topics, of course. So grouping, if you look back here, difference of squares has a formula that you can sort of apply and use, and it's pretty easy. So like x squared minus 25, you just square root both of those, square root of x and square root of 25, and you get x plus 5, x minus 5. It just works that way every time. So when you can use a formula for factoring, that's kind of nice. There are formulas for sum of cubes and difference of cubes, you can see, but they are lengthy and quite a bit more complicated. So when we get to those will be the last couple of problems I do. You know, there's a formula, which is good, but it's not easy, which, you know, not so good. Grouping, there is no formula. I'm just going to teach it as I go. It's a method. You just have to see it a few times. Quadratic form is actually pretty easy because it's the same as trinomial factoring, which we've already covered. Basically, a quadratic form is a polynomial where the degree here is twice as big as that power, and as long as that happens, I mean, it could be a 6 and a 3 or an 8 power and a 4 power. Anytime that happens, you can use the regular factoring we already know how to do. But it's technically new, so I'm going to treat it like a new thing. Probably the most complicated thing will be the sum of cubes, difference of cubes, and as I said, when I get there, we will deal with it. One more thing, back to the grouping. I didn't specifically teach this before as grouping, but I kind of went over it in another lesson a while ago, so it may still look familiar to some of you. One last thing before we get into it. We'll be coming back to this as a reference. If we were in the classroom, I would have this as a poster on the wall. The cubic numbers. They're just, when you do the difference of cubes and sum of cubes, it's good to know things like 27 is 3 to the third power, or 125 is 5 to the third power. That's just good knowledge to have. You probably already know your square numbers. For example, you know that 4 is 2 squared and 25 is 5 squared, and maybe you've learned all the way up to 12. 144 is 12 squared, and everything in between. Most people have good knowledge of that. Just because you learn your times tables in elementary school, middle school, whatever, but you typically don't learn your cubic numbers. So it's important. We'll come back to that. This is not one of those lessons where after the first one or two examples you can probably go, because every so often the type of problem changes. So these two problems are very similar. Then you move to here, we're into something different, but these two are similar to each other. Then you move down here and we're into something different. So it's doubtful you'll be able to just stop and get to work. You might be able to skip ahead every now and then to make things go faster if you want to. So the directions are factor each. That's it, just basic instructions. I'm going to do the evens, ask you to do the odds. I do have it set up so that they're fairly similar with each other. So starting with number 2. To factor this polynomial, the first thing that you must notice is that each term has an x in it. So we can do common factoring and factor out the x. If we factor out that x, we divide it out of every term, we get x squared minus 5x plus 6. Now this is sort of more advanced factoring than we did before break. And the problems before break, this would probably be where you stop. However, after you factor out this x term, the remaining terms can still be factored, and that usually happens. So this is where we put x and x, and then we got to think of numbers to go here and here that multiply to equal 6 and add up to equal -5. And There's different ways to do this. I've done it by making a little chart of numbers like 1 times 6 and 2 times 3, and well, that's all there really is to go on. And to multiply to negative 6, you either need a negative 2 and a negative 3, negative 1, negative 6, positive 1, positive 6, positive 2, positive 3. The only pair of those numbers that'll add up to negative 5 is negative 2 and negative 3. If you can read that, it's kind of cluttered together there, but negative 2 and negative 3. And now this is what we would call completely factored. And of course you scroll down and check it, and there's the answer. So that was a combination of common factoring, trinomial factoring. Number 4 is going to be very similar. Again, there's a common factor of x, so you can divide out x. Once you do, you get x squared minus 2x plus 1. When you divide an x out of an x, it does leave a 1 behind. Sometimes students leave it blank or put a 0 there, but x divided by x is 1. Now, the polynomial in parentheses can factor out, and we need two numbers that will multiply to positive 1 and add up to negative 2, and that's simply negative 1, negative 1. So we get x times x minus 1 times x minus 1, and because these two factors are the same, the answer key is probably going to have it written this way, where they're sort of combined like that. So let's go down and check number 4. And there it is right there. Okay, number 6. Now, number 6 is different significantly. There are four terms, 1, 2, 3, 4. They do not all have an x, so we cannot do the common factoring here. It's not a trinomial. Trinomial means there are 3 terms, 1, 2, 3, so we can't do the trinomial factoring either. So this problem, 6 and 8, and then by default 5 and 7, are going to use this grouping method. So here's how the grouping method goes. You split the polynomial in half, and then you just look at the first 2 terms as a group, and you factor out whatever they have in common. So we are going to do common factoring from that group. So what do these two factors have in common? They can both be divided by x squared. X to the third and x squared both can be divided by x squared. And if you factor that out, take x cubed and factor out an x squared, it's just going to leave 1x. And I'm getting a little crazy with the highlighter and stuff here. If you take negative 2x squared and factor out the x squared, it's going to leave minus 2. Now do the same thing for the second half, or the second group. Do common factoring there. What these two terms have in common, they can both be divided by 2. The fact that there's a negative sign here is a little tip, though, that you actually have to divide out negative 2. If you divide out negative 2, it's going to leave x here, and then a negative 2 here, because negative 2 times negative 2 is positive 4. So if we divide out a negative 2, you get negative 2. Now, do you see how this set of parentheses is the same as that set of parentheses? When you're doing the grouping method, that has to happen. If that doesn't happen, you've made a mistake. But the fact that x minus 2 and x minus 2 is in both of them means that x minus 2 is one of our factors. Now, look at what's not in parentheses up here. X squared minus 2 is our second factor. So when you do the grouping method, the result here looks a lot like the result of like trinomial factoring, like what's here, but it's just a different method. But that should be the answer now to number 6. Let's check, and there it is. Now, if you didn't quite get that, that's okay. Number 8 is going to be sort of repetitious. So split this in half. Look at the first half. What do they have in common? And again, it's x squared. And if you factor out x squared, you're going to be left with 1x minus 5. Out of the next 2 terms, what do they have in common? Well, it doesn't look like they really have anything in common. But with a negative sign there, I can factor out a negative 1, and that's going to leave me with positive x minus 5. And by factoring out that negative 1, I have x minus 5, x minus 5. Those match. Like I said, they have to in order for this method to work. So now I can put down my two sets of parentheses, just like regular factoring, and one set of parentheses is x minus 5, and the other set I put this x squared minus 1. Now, this problem is a little extra because x squared minus 1 is a difference of squares. A difference of squares is this formula up here that we've looked at. If you have one square minus another square. So a square can be a variable with a second power, or it can be a square number like 25 or 9 or I don't know, 64, lots of numbers. Well, 1 is a square number. 1 is 1 squared. So this part here can be factored even more. You put down xx plus 1 minus 1. And then the first factor of x minus 5, you just bring that down, and that makes the whole answer. So number 8 looks like that. All right, so grouping. You do the grouping method, and sometimes you're done, and sometimes you find that there's an extra step you can do before you're done. All right, let's move on to number 10. 10 and 12, and then, of course, 9 and 11, are what we're going to call quadratic form. So here's what I want you to do. I want to look at this as, let's pretend this was just x squared minus 5x minus 14. If we wanted to do regular trinomial factoring on this, we put an x here, and we need two numbers that multiply to 15. Where did I get 15 from? I'm smart. Clearly that's a 14, right? Duh. Okay. Two numbers that multiply to negative 14 and add up to negative 5. So what multiplies to 14? Well, 2 times 7 jumps to mind, and if I had a positive 2 and a negative 7, they would add up to negative 5, right? So it's going to be plus 2 minus 7. So this is what that would be if you factored it. Only it wasn't really a 2 and technically there a 1, right? It's not a 2 and 1, it's a 4 and a 2. Well, that doesn't change this part of the problem. We still got the two numbers that multiply to negative 14 and add up to 5. We just have to deal with those higher powers. So the way to do it is basically the same. You put down two sets of parentheses. Instead of putting x in x, put down x squared and x squared. That's it. And then we still do plus 2 and minus 7, and there's the answer. So go down here and check it. And I believe, was that it? Is that where I am? I lost my place. Yep. I have it backwards. It's x squared minus 7, x squared plus 2, but that's the same answer, what they have in the answer key and my answer. So how did I know to use a 2 here and a 2 here? Well, because that's a 4 and a 2. 2 plus 2 is 4. That's pretty much it. If this problem, let's say this problem started out as x to the 6th minus 5x to the 3rd minus 14. If it looked like that, my answer would start out with x to the 3rd, x to the 3rd, and then what? Plus 2 minus 7. So really, it's nothing new and different. You just have to deal with the fact that there's bigger powers there, and it's not a hard thing. I mean, if that was a 6, then these are 3s. If this was a 16, then those would both be 8s, and so on and so on. All right, let's look at number 12, repetition. So I put down two sets of parentheses, and again, automatically, x squared, x squared. Now I need two numbers that'll multiply to 8, add up to 6. Let's see, how about negative 2 and negative 4, right? Negative 2 times negative 4 is positive 8. Negative 2 plus negative 4 is negative 6. Yeah, that's right. Let me erase all these little extra marks. Now, if I go and check myself, this is not going to be the right answer. Don't you hate when that happens? Let's look at number 12. And where is it? Right here. That's the answer we're looking for. So what's going on? Well, just like what happened a few problems ago, what we have here is a difference of squares. A difference of squares, again, is whenever you have one square minus another square. That can be x squared or it can be a square numbered, as long as there's a minus sign in between there. Man, I highlight stuff way too much, don't I? So anyway, right here we have x squared minus 4. So this is a square minus, that's where the word difference comes from. And then 4, of course, is 2 squared. So that's a square number. So that tells me that I can factor this a little further. The first factor is done. You can't do anything with that. It is a difference, but 2 is not a square. So you can't factor that. But the rest of this will break down into xx plus 2 minus 2. I believe the answer key has it x plus 2, x minus 2, x squared minus 2, just the same answer in a different order, but it's the same answer. All right, 14 and 16 will make us done. Number 14, all right, remember from what I just said a minute ago, a minus sign is what we call a difference. A third power is a cube. And then 8, if I go up here to my little chart, 8 is 2 cubed. So this is a difference of cubes. When you approach a difference of cubes, you need the formula. Now I'm not going to scroll up and down, because it'll probably make you nauseous. I don't know. The formula looks like this. I'll just copy it down. So a minus b, a squared plus ab plus b squared. That's barely legible. Give me just a second. Okay, so in this problem, the a from the formula is x, so I'm going to write x cubed. And the b for the formula isn't 8, it's going to be 2 cubed. So you have to know, where did the 8 come from? It comes from 2 times 2 times 2, 2 to the third power. So when I go to write my answer, basically I'm going to duplicate this formula. Everywhere that you see a letter 8, I'm going to write an X, I'm sorry, a letter 8? Duh. Every time you see a letter A, I'm going to write an X, and every place you see a letter B, I'm going to write a 2. So it's x minus 2, x squared plus x2 plus 2 squared. Now this isn't the final answer. There's a little bit you can do to make this look more appropriate. For example, x2 isn't typically the way we write algebra. We'd write that 2x. And then 2 squared, everyone knows 2 squared is 4, so you simplify that. But this is the answer. X minus 2, x squared plus 2x plus 4. Let me go down and check number 14. And there it is. Now you might look at this and say, well, that's a trinomial. Why don't we do trinomial factoring? Well, you're not going to find a number that multiplies together to equal 4 and adds up to equal 2. It's just non-existent. You can't do it. So on these difference of cubes problems, there will be no extra step where you can factor it further. It just doesn't happen. Same thing on the next problem when we get there. Oh, yeah, sorry, I got a little confused. Number 16 here. This one is a sum of cubes. It's got its own formula, which I'll write down. We're going to use the formula, but at the end it won't break down any further. So what do I mean by this? All right, let me get to this. So the formula is a cubed plus b cubed equals a squared plus b squared times a minus ab plus b, squared. Oh, wow. Let me start over. I just about messed that all up, and that was ridiculous. A cubed plus b cubed equals a plus b, a squared plus ab plus b squared. My mind faltered for a moment. So in this problem, a is going to be my x, and b, well, I got to take 64. I got to go check my little chart up here. 64 is 4 to the third power. So I need to make this into 4 to the third power. So when I factor this, I'm going to look at my formula, which if you look, it's like some close together parentheses and some far apart parentheses. Oh, gosh darn it. I wrote the formula wrong again. That plus sign there is supposed to be a minus sign. Oh, we'll get there. We'll get there. Okay, so Everywhere in the formula that you see the letter A, I'm going to write an X. And here, I'll color code it. Everywhere in the formula you see a letter B, I'm going to write a 4. So here goes. X plus 4, x squared, minus x4 plus 4 squared. See that? Everywhere there's an A, I put the letter X. Everywhere there's a B, I put a 4. Now all you have to do is some basic simplification, like x4 is really 4x, and 4 squared is really 16. And then that's it. That's your answer. As long as you have the right formula. Geez, man, I wrote this down wrong twice. So when you go to do your homework, make sure you have the formulas handy, or use this one so you can just look left and right and use my examples. Now tomorrow we're going to do all of this same work, but then there's going to be more steps after it to solve these equations. So it's really important you understand the basics of how to do all this kind of factoring. So make sure you do this assignment. Contact me if you have questions. This might be a good topic where you get on YouTube and you type in factoring in the search bar and look up extra videos, or if you have any friends or relatives who did well at Algebra 2, if you need help, they can walk you through it. But contact me if you need help as well, and we'll do everything possible. Otherwise,